Imagine two industries that, until just recently, felt like they existed on completely different planets.
Mm.
On one side, you've got hyperscale data infrastructure, you know, running at the speed of silicon, demanding more and more power, like right now.
And on the other side, you have nuclear energy. Massive, cautious projects that take decades to plan and build.
Exactly. But you don't have to imagine it anymore. That collision is happening. It is the new reality.
And it's driven by one thing, really, the simple, just staggering energy requirements of artificial intelligence.
Yeah, we're talking about a historic power deal. I mean, multi-gigawatt.
Yeah.
One that's forcing the nuclear industry to speed up and the tech world to, well, commit to a century-scale energy solution.
Okay, let's unpack this. We've got a whole stack of sources here detailing this.
Yeah.
This really unprecedented commercial agreement.
It's between Meta, everyone knows them, the global cloud and data powerhouse, and a company called TerraPower.
Right, the advanced nuclear developer backed by Bill Gates. And their goal is not small.
Not at all. They want to deploy up to 8 advanced nuclear power plants across the U.S.
And the key part is why. It's specifically to fuel Meta's data center demand, which is just surging.
The scale is really the headline here.
Mhm.
This partnership is aiming to inject up to 2.8 gigawatts of carbon-free baseload power into the grid.
But that's just the constant hum, you know. The really interesting part is the reactor technology they're using, the Natrium design.
Right.
Because of that design, the total dispatchable output can be pushed way higher. We're talking potentially up to 4 gigawatts using its built-in storage.
4 gigawatts?
Yeah.
From a single corporate buyer. I mean, that is a complete game changer for U.S. energy infrastructure.
It is.
We're moving way beyond just buying power credits. This is Meta actually funding the construction of dedicated power plants. So why now? What changed?
What changed is AI, the need for what's called firm electricity. Previously, advanced nuclear developers, they were always courting the big utility.
Traditional players.
Exactly. But that model is changing, and fast, because data centers, and AI hubs in particular, have become the fastest growing and most demanding part of the entire U.S. power market.
So let's talk about that term, firm power. For anyone listening who might be more familiar with renewables, help us understand why an intermittent source just won't cut it for a machine that can literally never turn off.
Well, it's the difference between a constant need and a variable supply. A massive data center, especially one running these huge AI models, needs power 24/7, 365 days a year.
With zero tolerance for outages.
Basically zero. And renewables like solar and wind are, of course, critical, but they're intermittent. The sun doesn't always shine.
So to back them up, you either need massive, expensive battery farms or you're firing up natural gas plants.
Precisely. If Meta is serious about scaling up its clean energy use while meeting that reliability standard, they need a source that delivers continuous baseload power without the carbon footprint.
And the old model, the one we always heard about, these virtual power purchase agreements, the VPPAs, that's great for your carbon ledger. But it doesn't actually solve the physical supply problem, does it?
Not at all. A virtual PPA is a financial contract. You're paying a solar farm somewhere to produce power. You get the carbon credits, but the electricity you actually use to run your servers,
It's still coming from whatever the local grid mix is.
which is often heavy on fossil fuels. This Meta deal is different. It's about dedicated, physical, clean, firm supply. It's Meta taking ownership of its energy future.
And we know TerraPower's CEO, Chris Levesque, has been pushing this really aggressive schedule. The sources quote him saying something like, "To address growing energy demand, we have to deploy gigawatts of advanced nuclear in the 2030s.
Yeah, that cadence gigawatts within a decade, that hinges entirely on finding a predictable, massive customer.
Someone like Meta.
Exactly. Levesque is basically admitting that utilities, they're bound by regulation, by tradition. They often move too slowly to meet this new AI demand curve. Meta provides the financial anchor to just jumpstart the whole thing.
And on Meta's side, this wasn't a snap decision. Their director of global energy, Irvi Perek, she noted this deal came from a dedicated nuclear RFP.
A request for proposals, meaning they actively went out looking for this.
Right. They ran a whole process to vet and select the best advanced reactor designs.
And that procedural rigor tells you this is a deeply strategic decision. It's not a PR move.
They're looking for reliability and scalability first.
They are, but they also cited the broader benefits, supporting U.S. energy leadership, job growth, and providing clean power not just for them, but for the communities around the data centers.
So let's get into the actual science. We keep mentioning this reactor, Natrium. What is this advanced design, and what's this integrated storage that makes it such a perfect fit for AI workloads?
Okay, so this is where the engineering gets really interesting. Natrium is not your granddad's light water reactor. It's an advanced reactor, specifically, a fast reactor design that uses liquid metal.
Liquid metal.
Yeah, in this case, molten sodium as its primary coolant instead of water.
And why does using sodium matter so much?
Well, a couple of reasons. Sodium operates at a much higher temperature than pressurized water, but, and this is key at atmospheric pressure, so it's inherently safer.
Okay.
But critically, those high temperatures let the system store huge amounts of thermal energy really, really efficiently. And that's the innovation. Natrium builds a molten salt energy storage system right alongside the reactor.
So break that down. How does that translate into power for the grid, the baseload versus this burst capacity?
So the core reactor just hums along steadily,
Right.
providing 345 megawatts of continuous carbon-free baseload electricity.
That's the firm power Meta always needs.
That's the firm power. But let's say an AI model spins up and suddenly demands a huge spike in power.
Which happens all the time.
All the time. The reactor can then draw on the energy that's been stored in that molten salt.
It's like having a giant thermal battery on standby.
It's exactly like that. The stored heat is quickly converted to electricity, letting each unit ramp up its output to a maximum of 500 megawatts for over 5 hours.
Wow.
And the sources detailed that a dual unit, which is what they're planning for the initial deployment, delivers 690 megawatts of firm capacity and can peak at 1 gigawatt when it's using that storage.
That flexibility it's just a powerful counterpoint to the variability of renewables, isn't it?
It is. You get the stability of nuclear with the dispatchable capacity you would normally associate with a natural gas peaker plant, but with zero carbon emissions. It's a clean, on-demand turbocharger for the grid.
So when the wind is blowing, Natrium provides the baseload. When it stops, an AI demand spikes.
Natrium steps up immediately.
Yeah.
And this isn't just a blueprint. TerraPower is already identifying initial sites. Those first units are targeted to be online as early as 2032.
2032. In nuclear terms, that is remarkably fast. Which brings us to the thorny issue of regulation and speed. I mean, none of this matters if the timelines drag on for decades.
Right. The historical risk.
So what's TerraPower's path to market, and why should we believe they can actually hit that 2032 target?
That speed is all about one thing: regulatory visibility. And that is Natrium's major advantage right now.
Okay.
TerraPower has already started construction on its first commercial facility. This isn't for Meta, it's their flagship unit, but it's targeting completion by 2030.
So shovels are already in the ground.
Yes. And here's why that's so important for investors. Natrium is currently the only commercial advanced nuclear design with a completed environmental impact statement.
That's huge.
It is. And it has a final safety review pending as part of its construction permit application with the NRC, the Nuclear Regulatory Commission.
So if you're an investor and capital deployment hinges on seeing a clear path to licensing, having those two boxes checked off it must significantly de-risk the whole project.
It changes the entire financial profile. Investors look at old nuclear projects and they see decades of uncertainty. It makes capital slow and expensive.
Right.
When TerraPower can show Meta, or anyone, that the big hurdles, environmental clearance, safety design, are already handled, the confidence in hitting that 2032 date just goes up exponentially. It makes the investment bankable.
So Meta isn't just buying energy here. They are providing the long-term revenue guarantee that validates the entire business case for this reactor technology. They're basically underwriting the industrialization of Natrium.
That's a perfect way to put it. They're transforming it from a demonstration project into a deployable commercial-scale technology. Levesque even noted that their supply chains are secure and the design work is done. Securing this corporate demand just stabilizes the entire pipeline.
So let's pull back and look at the bigger picture here. This really shifts how corporate power deals are done, doesn't it? We're moving away from paper agreements toward dedicated physical infrastructure.
We are looking at a completely new class of energy procurement. If Meta proves this is viable, other major digital and industrial players are going to follow.
Like who?
Think about major chip fabs, large-scale manufacturing, even cryptocurrency miners whose demand is also continuous and firm. These buyers will be drawn to assets like nuclear and geothermal instead of just intermittent sources.
Are you suggesting corporate demand could actually shift the fundamental economics of energy? Because historically, nuclear has struggled with massive upfront costs.
It absolutely addresses the economic problem. Nuclear thrives on guarantees of high constant utilization, that baseload guarantee. Meta, by committing to buy up to 4 gigawatts, provides that guaranteed customer for decades. It fundamentally improves the lifetime economics.
This leads directly into this idea that we're seeing in the source material, this idea of nuclear becoming the fourth pillar of energy security.
Oh, yeah.
We have renewables, hydrocarbons, storage. Where does advanced nuclear fit?
The sources position it as the missing piece, the fourth pillar that provides clean, firm, and scalable power. None of the other three can do all of that simultaneously.
Okay, break that down.
Renewables are clean but intermittent. Hydrocarbons are firm but not clean. Storage is clean and flexible, but it can't scale to the multi-gigawatt, multi-day capacity that AI hubs require. Not yet.
But advanced nuclear offers continuous, clean, scalable baseload.
That is the definition of a new pillar of energy security for the digital age.
And the geopolitical weight of this is immense. We know the U.S. has kind of lost its influence in nuclear tech over the past few decades. Meanwhile, China and Russia have been aggressively expanding overseas.
Yeah, this partnership is a vital step toward rebuilding that U.S. leadership. If Natrium succeeds here at home, it strengthens export prospects for U.S. tech, it creates high-skilled jobs, and it stabilizes the fuel supply chains for these advanced reactors.
So in a world where global competition hinges on who can power the most advanced AI clouds,
Having a reliable, domestically supplied nuclear technology is a critical strategic asset. You can be sure that other nations grappling with these same AI power demands are watching Meta's pivot very, very closely.
it's really a situation where the needs of technology are driving the resurgence of an entire industrial sector.
We've gone from a world where tech just passively consumed energy to one where tech demand actively dictates the future of the energy market.
So, to synthesize this for everyone listening, Meta's funding commitment is the catalyst. It's transforming this cutting-edge reactor design, Natrium, into a deployable solution that's basically tailor-made for the AI era.
Right. Offering both that stable baseload power and the flexible high-capacity power needed for those sudden workload spikes.
The Meta and TerraPower agreement keeps the United States firmly in the race to secure the clean, reliable power that's needed to scale up these advanced computing platforms.
It is probably the most significant private sector energy commitment of the decade.
And so here's the question that really lingers after digging into all this. The future growth of AI seems to now be inextricably linked to the success or failure of advanced nuclear deployment. What happens to the global energy mix? What happens to our climate goals? If every single tech giant follows Meta's lead and starts demanding its own dedicated clean farm power source, that shift would rewrite the energy grid faster than any regulation ever could.